Hi everyone. This week we're going to be moving on to a new chapter, which is going to be based on circles. So this lesson is just going to introduce to you um, the basic things you need to understand about a circle before we move on. So in this lesson, we're going to be able to do two things. We're going to be able to define a circle and its essential parts, and then we're also going to be able to calculate the circumference, the area, the arcs, and sectors of circles. And we're also going to be solving for problems that are related to those items as well. So let's go ahead and continue. So there are a few things that we need to understand about a circle. So the first thing we need to know is that a circle is basically the set of points that are all equal distance from the center, right? So if we were to mark the center somewhere in our circle, let's say the center is somewhere around here, right? Then every point on the circle is going to be the same distance from this point, right? So if I pick a point on the circle, let's say this point right here, then the distance from that point to the center of the circle is going to be exactly equal to the distance from some other point to the center. So if I pick another point on the center, right, so these two are going to be exactly equal to each other, and that distance is going to be known as the radius. So if I zoom in here, this distance, and this should be a straight line, right? So we're just going to pretend this is a straight line, but this is known as the radius, right? That's a piece of the radius. And if I were to draw a straight line going from one point of the circle to another point of the circle that goes through the center, then that's going to be known as a diameter, right? So let me see if I can draw a straight line here. So let's do a different color. Let's do green. All right. So let me try diameter. So I pick a point on the circle here, picking a point on the circle there, and we're going to go straight across and go through the center, and that is known as my diameter, right? So this is going to be a diameter. So let me zoom in here. So this is known as the diameter, right? And the key here is that it has to go through the center of the circle, right? That's the whole point for all of these, right? The radius has to touch the center. The diameter has to go through the center. And then we have a couple things that don't really need to go through the center. For instance, a chord. So a chord is just the distance between any 2 points that are on the circle, but they don't need to go through the center, right? So let's say I wanted to draw a straight line from my purple and my blue point on the circle. So there's my purple and the blue one. If I draw a straight line between those two, right, that's going to give me a chord right there. So let's go ahead and write it in. So now here I've got a chord. So this is known as a chord. Okay, so these next two parts, the next two terms, they're called minor arc. So we have something called a minor arc. So an arc is just going to be a part of the circle. So it's just going to be a part of the circle, right? So if I look at this guy right here, this piece that I just highlighted in the blue, that is an arc. Now this is known as the minor arc because this is the shortest arc between 2 points on the circle. And then we can also have what's called a major arc, right? So the major arc is usually the longest arc. So if the highlighted portion is the shortest distance, then the longest would be going the other way around. So this would be your major arc there. Okay? Okay, so let's go ahead and apply the definitions that we just learned. So this first question is saying name the circle. So typically the way that we name circles is we're going to name them based off the center of the circle. So in this case, the center of the circle is just going to be that N, right? So we see right in the center, I have that little N right there. So that's what the name of it is going to be. So we can say, there's a couple of ways we can say it. We can say circle N, right? We can just spell it out, circle N. Or a lot of times we even use this little symbol that is shown here, right? We just say circle and then N. Okay, so either one is fine. All right, next part, it says identify each. Identify a chord, identify diameter, and identify a radius. So which of these is going to be a chord? It's going to be EF. Which of these is going to be a diameter? It's going to be DF. Then which of these is going to be, whoops, sorry about that. Which of these is going to be a radius? So we have a few radius here. One of them would be, we can say D to N. We can say C to N. We can say F to N. And even E to N, right? So these are all examples of a radius. So let's see if we can solve some of these problems using their relationship. So if C to N is 8, so from C to N, if this measure here is 8, okay, centimeters, find D to N. Well, by the definition of a circle, all radii are equal, right? The radius is always equal. So if N to C is 8, then so is D to N. It's also 8. So D to N is also equal to 8. For number 4, if EN is equal to 13 feet, what is the diameter of the circle? So if E to N, let me go ahead and erase the 8 now since we're in a different problem. If E to N is 13, then what is the diameter? Well, we know all the radii are equal, right? So N to F is 13, D to N is 13, and so is C to N. Well, we know the diameter is a distance from one end of the circle to the other one going through the center. So if I were to combine those, that would be a total of 26, right? I would just do 13 plus 13, and I'd get a diameter of 26. So I wanted to introduce 2 vocabulary words that we are going to be using as we solve some problems later on in this video. So we first begin with an inscribed shape. So the way we're going to define these is these are all going to be either inscribed or circumscribed around a circle. So inscribed is going to refer to the polygon other than the circle. All right. So in this case, an inscribed polygon has all vertices that lie on the circle. So what I'm saying is that the shape is inside of the circle. So this keyword inscribed is just describing the shape. Okay, it's not describing the circle. The circle is not on the inside. The shape is the one that's on the inside of the circle. So that's kind of how I always remember it. But to be specific, an inscribed polygon, it has to have all the vertices. All the vertices have to lie on the circle, right? Otherwise, technically, it's not inscribed, right? All those vertices have to lie right on that circle. Then we have circumscribed, right? So circumscribed just means that the shape is now going to be on the outside of the circle, right? So the shape is on the outside. And now if we see the image, we can see that the circle is on the inside and the shape is the one that's on the outside. And we can see that the circle is touching the each side of the polygon. So I wanted to quickly review 2 common concepts that we apply to circles. They're known as the area and the circumference. So let's first go over the circumference, right? So the circumference of a circle, right, is just going to be the measure around a circle. So basically, imagine if I took a piece of string, I wrapped a piece of string all around the circle, and then I took that piece of string and I just laid it out, right? Whatever that measurement would be, that's the circumference, right? That's going to be the circumference of it. So the formula for that is going to be the circumference of any circle is equal to 2 times pi times the radius of the circle, right? So in this case, the C is going to stand for circumference, right? This stands for the circumference. The circumference and then the r is going to stand for the radius. And then the pi, this is going to represent a constant, and we're just going to approximate it as 3.14. Okay, most calculators have a pi button, which you can use as well. We are going to calculate the circumference and the area using pi as an approximation, and also leaving it in its exact form with just the pi. So let's see what that looks like. We'll see what that looks like in the examples. The other concept that I wanted to go over is the area. Okay, so the area of a circle is just a measure of how many square units are inside of the circle. And the formula for that is going to be the area is equal to pi times r squared. So again, really quick, the a is just represents the area. The pi, we know that's a constant, 3.14. And then r is my radius. Right, it's whatever the radius is, and it's going to be squared, so just be careful with that. Okay, so I have two examples at the bottom. Let's go ahead and look at those. Okay, so let's go ahead and start off with example number 1. So with example number 1, I want to find the circumference and the area of my shape over here. So this is not like a typical question. We're going to have to do a little bit of extra work before we can solve for it. But I like to start off with something a little bit more challenging, because I know that we're all able to kind of deal with the easier types of problems. So, okay, so let's go ahead and first look at example number 1. So it's asking us to find the circumference and the area. So if I write down the formula for the circumference, right, we're going to see that the circumference is just going to be equal to 2 times pi times r. The problem is that we don't know what the radius of the circle is, right? Remember, the radius of the circle is going to be the distance from the center to a point on the outside of the circle. We have no idea what that measurement is, or we have no idea what this measurement is either. So our goal is to find whatever the measurement of one of those pieces is. So what I notice is that inside of this circle, I have a square, an inscribed square. So a square is going to be made up of 2 triangles. So I have some triangles there. All right, if that's 3, this is going to be 3 centimeters. And this is a 90-degree angle because it's a square. And hopefully you guys remember special right triangles, right? If this is 90, these have to be 45 and 45. Because since the 2 sides are equal, the 2 angles have to be equal. So 45 is the only angle measurement that will add up to 90. Alright, so this is a special right triangle, so I hope you guys remember your formulas here. Remember, this is your A, this is your A, and this is a radical 2. So all we have to do here is we're just going to plug in A, right? We know A is 3, right? A is equal to 3. Right? A equals 3. So wherever I see an A, just going to replace it with 3. Perfect. So now I know the hypotenuse is 3 radical 2. But the hypotenuse of this triangle is the whole thing. I only want to know, or at least I only need to know, what is just a piece of it, right? What is just this piece? Well, if the whole thing, actually I'm going to do it in a different color, right? Because red is the length of the whole thing. I want to know just this piece. So if 3 radical 2 is the whole thing, then how do I find just this piece? I just need to cut it in half. So this piece is going to be equal to, is just going to be equal to half of 3 radical 2. So 3 radical 2, and then just cut it in half. 3 divided by 2 is just 1.5. So that's what my radius is. So I'm going to go ahead and just plug that into the circumference now. So the radius is just going to become 1.5 radical 2. And I'm just going to bring everything else down, right? I'm going to bring the 2, I'm going to bring the pi, and I'm going to bring the 1.5 times radical 2.